more on compounding and why it is difficult to implement. So first of all, it works only in long term, right? Which means you need to show delayed gratification, which means benefits will come towards the end, right? So you should not interrupt compounding. Only then you'll have sizable benefits towards the end. Now that is something which is very difficult to practice. You probably might have heard the story of a king and a beggar uh, who asked for his reward for as rice grains. And beggar said that on a chessboard, 8 by a chessboard, just place one grain on first square and then keep on doubling it till square number 64, and that's the rice I want to have, right? And king grossly underestimated it and said that okay, it's easy, wish granted, right? What he did not realize was the amount it uh, becomes, right, after compounding for 64 times is 180 plus billion metric tons, right? Which is equal to 350 times of global annual production of rice. So it's enormous amount which usually we cannot grasp, right? Here is one more interesting example. If we were to play a game, right? You pay me 1 rupee on one day, right? And then keep on doubling that amount for every day for 1 month. And in return, I'll pay you 1 crore rupee per day, right? I'm not sure how many will take that bet. So let me increase the stakes. I can pay you 2 crore rupees per day, right? For 1 month, 31 days. If you calculate that, it looks something like this, right? So the amount which you start from rupee one and then keep on doubling at the end of 31st day, if you count all of them together, it becomes 214 crore, right? As opposed to the amount which I would end up paying, probably 30 crores or 60 crores, right? Now, what you need to see here is the amount actually really becomes big in last 8 or 10 days. Till date 20 or date 21, it is just 10 lakhs, right? And that's what I meant by you need to show delayed gratification and it works only in long term, right? So if you put it on graph, it looks something like this. This is classical exponential curve, how the doubling or any kind of exponential function looks. So if you see, it is hardly noticeable. There is hardly a dot which you can visualize, but there are tremendous gains towards end. Now, why this is significant is we often talk about Warren Buffett, who has compounded his wealth over last 60 years at the rate of about 19 to 20%. And his personal wealth actually mimics that graph which we saw earlier, right? So if you see, he's now 95 years old, still healthy and active, and more than 100 and I think 10 or 15 billion dollars, right? So this is exactly the exponential curve which I was talking about earlier. Right? So let's go back to the three avenues we initially saw for compounding. Start with bigger initial capital, have a higher rate of compounding, and have a long-term view, right? Now, higher rate of compounding, if you can get consistently, nothing like that. But even the smartest of the investors have not actually earned more than 15 or 18% of CAGR, compounded annual growth rate, over a long period of time, right? But that kind of rate is sufficient to build enormous wealth if you have a long time horizon.